And for the next maybe five or so minutes, we'll be waiting for more participants. And so I'm going to give you a brief overview of Lula Technologies. We're based in Riga, Latvia. We are a manufacturing company, and we build our software and hardware from scratch. So it's a full cycle from idea to the ready-made device. And we specialized in measurement and test instruments. And here you can see the features that we're trying to emphasize as our advantages. So we provide versatile equipment, the equipment which can serve as a vibration controller, as a data acquisition system, as a calibration system, as a portable data acquisition system, all in once. In one, our solution are tailor-made, so we really listen. And if there are any features which you need, we always provide this direct contact to the development engineering team. We do focus on support, so it's on 24/7 and available via different media, via different means. We provide free online education, free software demos, so everything to try this technology out before committing, before making an investment. We also do free software updates, so it means that once you have our equipment, you are guaranteed that it's going to work for many, many years on uninterrupted. The solutions that we come up with cater for automotive, aerospace, research and development, and other industries. Now on to today's webinar. So how do we suggest someone moves from newbie to pro? After you have covered sine, random, and shock, we suggest that maybe you could move on to the superimposed test. So sine and random on random mode. So we'll be talking about the peculiarities of these tests, some specific features. We also want to give you a peek on multi-sine. So it's like an extension or a development of sine. We will feature complex shock types like shock response spectrum and transient time history. So for users of shock, that will be interesting. And we also do an overview of field data replication and fatigue damage spectrum. So different ways of implementing or reproducing real life data or something close to real life data on your testing set. So we will overview them and we will show how it is quite easy and intuitive in TestUp software. So we'll show you the workflow. Yeah, and basically that is. So I think everyone who wanted to join is already here. So we may as well move on to the main part of the webinar. And without further ado, I give the floor to Alina.
Yeah, so let's begin our webinar. So in the first part of this topic, we discussed the importance of advanced features, which are hidden inside three basic tests, sine, random, and shock. And today we continue our discussion, and I would like to start with the superimposed test type. So the first obvious recommendation would be to explore the capabilities of superimposed tests, sine on random, random on random, or the combination of the two. It sometimes may occur that sine test or random test alone end up in under-testing your device under test, and the result of which may be very critical. If you'd like to subject your device under test to a heavier impact, superimposed tests are available. Besides, they may imitate certain operation conditions much closer, like those on board a helicopter or other aircraft, for instance. The capabilities of the software allow superimposing up to 12 sine tones or random bands over the base random spectrum. And it is also worth mentioning that notching is also available for superimposed tests. Of course, SRoR is also part of many universal standards now, so it may already be a requirement in your field or country. Sine random on random test includes the following types. Sine on random. So this, in the course of this test, the sum of random signal and sine waves of fixed or swept frequency is delivered to the shaker. In the course of a random on random test, several random signals are delivered to the shaker, so the base signal and superimposed signals. In this test, the frequency range of the superimposed random bands may be constant or may vary. Sine and random on random is a combination of two previous options, and sine on sine is a sum of sine signals with the fixed or swept frequencies which deliver to the shaker. So now let's switch this screen and let me open test up. So we will do this way. Good, so let's choose sine and random on random test. We press create test button. And the first tab you see is a profile tab. This is the main random signal profile, which will be used as a base signal for the test. And let's enter the profile. We will create a straight line from 10 Hz to 4000 Hz. And its amplitude will be 0.0011 G squared per Hertz. After that, we go to Sine on Random tab. And here we enable Allow Sine on Random option in the window below. Now we're ready to create sine profile. It will be placed over the random profile we created in the first tab. For this test, I suggest creating all three available sine sweep directions. So let's start with the fixed. We set the frequency of sine to 100 Hz and the start amplitude is 1 G. Here you can choose the measurement unit of the amplitude as in a regular sine test. It can be set in acceleration, velocity, or displacement units. Next, we add another line and we will configure it as start and start sweep direction. We set start frequency to 150 Hz and its amplitude to 1.5 G. The end frequency will be 300 Hz. And the amplitude equals 2. After that, we configure and start and sweep direction. It will be created in the most complex way with the set start frequency to 1000 Hz, amplitude to 1 G, and the end of the line will be 3000 Hz. And amplitude equals 3. Now we will split this profile into two sublines. So we press add a subline. The first one will be from 1000 Hertz to 1500 Hertz. Sorry. Amplitudes from 1 to 1.5 G. And for the second one, the frequency is from 1500 Hertz to 2000 Hertz and amplitudes from 1.5 to 3 G. So let me enter these numbers. Now we're ready to continue. We can apply the settings and run the test. So let's press apply button. Okay, and the duration of the test is 10 seconds. So let's start and open oscilloscope in spectrograph mode. So we need to wait before we can see the graph. So after the startup, you can see that we have our base random signal and 3 sine waves running over it at the same time. So here is how it looks like. Now let's stop the test and continue with the discussion of random and random test type. So let's open test settings. And in this case, we will leave the profile tab with the settings from the first example. Next, we will untick allow sine on random test and go to the second tab, which is called random and random. Here we can set the random signal, which will be placed over the base random signal configured in the profile tab. So let's begin with this fixed sweep direction. In the sweep width, we enter 300 Hertz. The frequency where this random will be placed is 1000 Hertz. The amplitude is 0.05 G squared per Hertz. So we need to do it this way. And let's press apply button. So here in the graph, we can see the way random and random look like. And in the graph, you can see that we have 1000 Hertz frequency in the middle of the waveform, and the ranges from 850 Hertz to 1150 Hertz. After that, we will okay. So so this is how random and random test type look like. In case of sine and random test, we will enable both sine on random and random options. All these signals will be mixed and generated together. To do this, you need to enable both features on their tabs. So let's go to test settings. We have allow random and random tab and allow sine on random option. And the final way to configure the test is to set sine on sine option, and this option disables the main profile and random tab. To use this feature, we enable the sine on sine and can leave the settings from the previous test. In that case, only the sine signals will be generated. I would like to discuss whether mixed tests are as complex as they may seem to be. Well, at first glance, terms like sine on random, and especially sine and random may sound like something complex. In reality, this is not the case. There is nothing fundamentally new about superimposed tests. They use exactly the same basic signal types that you already know and already know how to configure. Moving on, we can suggest a way to maximize an all-too-common sine test, and this would be acquiring a multi-sine or advanced sine option. So let's open the presentation. So basically, multi-sine or advanced sine option is the same sine test with familiar settings and resonance search track and dwell submodule, but allowing for running up to 8 sine tones simultaneously. Just think how significantly it changes the impact. If you run, for example, 6 sine tones at once, it helps you speed up the test by 6 times compared to regular sine, where you just run each tone in turn. Of course, such development is not applicable to every test procedure, but very often it may considerably improve the test practice. In the automotive sphere, advanced sine is practically a standard procedure by now, for serial tests of automobiles for sure. So let's open Test tab and configure advanced sine test type. So let's choose advanced sine. We press Create Test button. So as you can see, the Profile tab is similar to the regular sine test profile. Here we can enter the profile lines by entering their frequencies and amplitudes, change sweep rate, abort, and tolerance. Let's create a simple sine test profile. Start frequency is 50 Hz. Start amplitude is 10 meters per squared second. And frequency is 500 Hz. And amplitude 20. On the right side, you can see additional options for profile creation. And using calculate point of intersection, you can find the intersection point of two profile lines. If you use calculate sine point, you will use a special sine point calculator, which will help you to find acceleration, velocity, displacement, and frequency. And the final button, Calculate Maximum Profile, will create a test profile using the maximum values of your shaker. In the bottom of the tab, you can recalculate your profile for the desired period of time. After the profile is created, let's create a schedule for the test. We can run advanced sine in multiple different configurations. So we can run it as a regular sine test, as a multi-tone sweep, as a multi-sine, and in a stepped sweep mode. Today we will show you the configuration of multi-sine test mode. While using this feature, we can create an advanced profile with multiple different commands, which will run at the same time using multiple sine tones. In the schedule, we need to first add the start and the end test commands. So it is multi-sine and multi-sine commands. After that, we will, so let's do it this way. We will add it in the end. So after the multi-sine, we add two sweeps. The first sweep has frequency from 50 Hertz to 70 Hertz. The second sweep has frequency from 100 to 120. We also add hold frequency commands. We have two today. And we will hold frequency at 300 Hertz and at 500 Hertz. So let me check the profile. Okay. So let's press apply. Oh, we forgot about the end multi-sine. Now we are ready. So let's see how does it look like. So we need a few moments to see the graph. So here we can see these sine tones. Okay, so let's stop the test and move on to the next test type. And it is field data replication. The idea of field data replication is that you replay the previously recorded time domain data on your shaker. If the actual condition of operation of your device under test are at hand, it makes sense to record those with the recording option of desktop in your lab or a portable ruler recorder or in a different way, and then simply reproduce it on a shaker. It would make sense to compare the FDR results to the results of testing your device under test with regular mathematical modules like random test. Comparing field data replication to basic test types, there is a notable distinction. While sine test type applies a generated periodic waveform and random test type utilizes a spectrum of varying frequency signals to simulate unpredictable environments, field data replication directly reproduces the recorded responses from the field. So what products does SRoR offer for data recording? SRoR offers a range of products for data recording tailored to meet various needs. So let's look at this slide. The SRoR-19 can be mounted on vehicles or aircraft to record data from connected sensors, making it ideal for monitoring performance road or flight conditions. The SRoR-17 can be placed on transportation containers, ensuring vibration data is captured throughout the shipping process. For more complex recording needs, the RLC-25 can be utilized in the lab to record multiple channels simultaneously. All of these systems record data in the proprietary ruler valve X format. However, they are easily convertible to basic recording formats. So let's open Test tab and configure the field data replication test type. So here's field data replication. We press on Create Test button. And we need to choose a file with the recorded data. So here it is. If you don't have a recorded signal, you can use different data types. We have a built-in converter from text file, CSV format, or we can work with audio files. You can press import and select the file if you want to convert it into WowFix format. So after that, we go to Schedule tab, and the main command for field data replication is called play. We select the file and set the duration, so for example to 10 seconds. Next, we need to check the settings in the Control and Limit tab. And when you hover over the parameter on the Control tab, you can see its brief description. So for example, startup control voltage is the maximum voltage that can be delivered to the output until the system discovers that there is response. Or startup end level is the level of acceleration on reaching which the system startup stops and the test starts. So these are a few safety features. In the Channels tab, we use the pre-created channel configuration. So we have here 4 channels with the sensitivity of 100 millivolts per G. The first channel is control and the other are measuring. And we can apply the settings. And start the test. So to sum up, during the FDR test, you can run the recorded signal from your device on your system and create a vibration test using this signal. Of course, the options of random tests such as spectrum import and fatigue damage spectrum that we mentioned at the first part of the webinar, they will also come in handy when you are working with the real data. So while we are creating the graph, let's go back to the presentation and have a look at the comparison between these test types. So as I said, FDR allows you to replay the previously recorded time domain data on your shaker, so it is a direct replication of the recording. Spectrum import is a feature of random test, and it allows the user to transform a recording of your real-life data to frequency domain data using the fast Fourier transform. This feature allows for calculation of random profile based on spectrum calculation from WowFix file. And FDS, fatigue damage spectrum, is also a feature of random test, and basically it is a fatigue calculation based on Palmgren minor rule. And the main advantage of fatigue damage spectrum is that it helps to accelerate the test. It allows to calculate fatigue damage based on the recorded data and then synthesize a signal which would produce the same damage in a shorter time. FDS is recommended if you want to test the device under test to destruction, but do not want to run tests of long duration. So last but not least, if you are a user of shock test module, you may want to add complex types of shocks to your testing menu. So these are shock response spectrum and transient time history. Let's begin with the SRS. SRS test type is used to characterize the frequency response of shock environment to estimate the maximum dynamic response to structures. It aims to produce and excite several different oscillations and resonance frequencies inside the device under test. These calculations can follow an arbitrary list of frequencies, but usually a certain n-octave range is taken for this purpose, so third octave, quarter octave, etc., depending on the technical task. A few words about the benefits of SRS test. So it allows for more accurate simulation of real-world shock events. It can be used to test multiple scenarios quickly and efficiently, and it helps to reduce costs by identifying potential issues early in the design process. So let's continue in test tab. Let's click on SRS test type. So the start frequency is 100 Hertz. Start amplitude is 2 millivolts per second squared. And frequency is 2000, sorry. And amplitude 2. Next, we enter SRS parameters into settings group. So we have analysis parameters and synthesis parameters. In analysis parameters, you can see that you can choose if you want to run it with damping factor or Q factor. So the damping factor characterizes the speed of amplitude decreased during the shock, and the Q factor characterizes the waveform sharpness and its quality. And next, you can choose synthesis type. So we have 1/nth octave series, wavelet frequencies, SRS frequencies, linear step. If you select the octave series option, you will need to specify the mil-STD standard, start and end frequencies of the synthesis, and the part of an octave to analyze. The second option uses the frequencies from the wavelet tab. SRS frequencies, so the third one uses frequencies from the profile tab. And linear step allows the user to specify a linear frequency step for analysis. As you can see, test tab offers a wide variety of wavelet types. So we chose octave series and we selected mil-STD standard, entered the frequencies and octave for an analysis. Next, let's enter pulse duration. So for example, it will be 100. Let's go to the schedule tab. Here we will enter the number of shocks. Let it be 100 shocks with 100% level and 1000 period. Next, we go to the control tab and enter the parameters in the control tab. Here we won't change anything, so we will save it as it is by default. In the limits tab, you need to check the manufacturer and the shaker model. Next, you are to check the channels. And we are ready to start the test. So here is the graph that you will see at the end. So let's go back to the presentation. And another advanced form of shock test is transient time history. It is considered to be an advanced form of shock vibration test type, which captures a complete temporal profile of the shock input and records the precise amplitude and timing of the shock waveform at each moment during the test. The software forms a shock accelerogram by multiplying the base signal by an envelope. As the base signal is always formed in the range from -1 to 1, after multiplication the acceleration by module will not exceed the envelope. The envelope, together with the base signal, provides smooth rise of the signal at the start of the accelerogram and smooth signal fall at its ends. In simple terms, transient time history can be characterized as a high-amplitude shock that gradually dampens out over time, much like a ball dropped from a table where each subsequent impact is lower than the previous one. Transient time history allows the user to simulate real-world shock transients on the object. It evaluates how components respond to transient loads like shocks and impacts, making it more suitable for assessing scenarios where dynamic behavior and sudden changes are crucial, like in crash testing or launch conditions. So let's move on to the configuration of this test type in TestUp. So we need to create a new test profile. Today we're going to make a square wave shock. So let me choose it. So the amplitude will be half G. We will have 10 cycles with frequency of 150 Hertz. A few words about the chosen wavelet. The square wavelet form is characterized as a wave which consists of fixed frequency square pulses multiplied by trapezoidal H smoothing function. By changing the ramp cycles value, we can change the number of cycles for the signal rising and lowering the level. So let's set it as 3. After that, we pressed synthesize button and now we can see the shock wave. In the bottom of the profile tab, you can see the maximum values for the profile, information about the shock duration, and calculated TE upper parameter based on millisteady standard. Let's move on to the SRoR table, and here we need to enable use SRoR table. And if it is active, the user can enter the parameters in it. Otherwise, the system does not use the data specified in it. In case that the box is not checked, the type of SRoR synthesis, SRoR frequencies is not possible. So let's enter the linear profile from 10 Hertz up to 500 Hertz and 3G amplitude. Next, we open SRoR parameters and enable make SRoR calculations. In this case, SRoR will be calculated and you will be able to see the results on the graph. In the settings of SRoR tab, we use the parameters by default, and then we go to the schedule tab and add 2 more commands. So we are going to enter 10 shocks in the first and the second lines and 100 shocks in the third one. Next, we go to Control tab, and here we leave the main settings by default. The Control tab contains a number of fields to which the parameters are entered. Based on these parameters, the system controls the vibration test. Next, we are going to the Limits and Channels tabs, and here we will leave all the settings by default. So let's apply these settings. Okay, so we can start the test. So while it is creating, we can check the chat and see if there are any questions. So today we told you about the advanced test types like superimposed test, multi-sine, field data replication, shock response spectrum, and transient time history. We guided you through these options in TestUp software, and I think that we made sure that some of these modules are not as complicated as they may seem. So now we're having a Q&A session. We will be waiting for a few minutes.